So next here, we want to talk about inverse functions on a graph. So let's start by just finding this inverse. So I thought we'd just do this with the table here. So we have our inputs here, our outputs here. So let's just quickly make our table for f inverse of x. I'm going to try to color code this so the inverse stays in red, and then the function, I'm probably going to graph it in green here. So remember that our outputs and our inputs switch. And so here, my outputs before become my new inputs. So 1, -2, 3, and 0. And then my old inputs become my new outputs. So -3, 0, 2, and 4. Right, and then if I want to graph these points, let's graph the function first. Right, I would go over to 3 and up to 1. Right, I would go to 0 and then to 2. Right, I would go from 2 and then up to 3. And then I go over to 4 and then to 0. So let's just mark these. This is 4, 0. This is 2, 3. This is 0, -2. Over here we're at -3, 1. And then I just want to do the same thing with the inverse function and see if we can decipher a little bit of a pattern here. So here, my first input is a 1, 3. So over to 1, down to -3. I may have said positive 3, but of course -3 here. This is 1, -3. -2, 0. So I'm going back to -2 here. So this is -2, 0. 3, 2. So I'm going over to 3, up 2, really close to the other point. 3 and 2. And then going left and right nowhere, but I'm going up 4. 1, 2, 3, 4 units. Up 4 units. So I'm at 0, 4 here. And what happens here is, of course, our old points, so the function, right, a function might have the point x, y. The inverse function, is just, again, our outputs and our inputs are switching, so it's like it's y, x. Of course, this is still horizontal. I'm just switching where they were here. Our x, right, became our output, y became our input. Right? So that's how we find points. We just switch them up. But also, if we look at this graph, something that might be a little bit hard to see with just points here, but it happens. Let me get a straight edge here. All right, just one second. Folding up a sheet of paper to make a straight edge. Is if we graph a line here, if we graph a particular line, in fact, probably the first line we ever learned to graph in the world. We graph the line y equals x. Y equals x, like the first line we ever graph in the world. Right? We see that these points are symmetric on them, that they're just opposite of this line. If I'd drawn better, it would be even better here, but we see that these are just mirrored, essentially. If y equals x is the mirror, one side should be an exact replica of the other side. Right? So for inverse functions and a function, so this is like a relationship between them. Right? Functions, right, are mirrored over y equals x to their inverse. To their inverse. And that's because we're switching x and y, and so of course anything that had the same x and same y value stayed in the same place, right? If my input here, if I had like a 5, 5, if I flipped the x and the y, that would still stay 5, 5. Right? And so I'd end up with a point on both, right, that wouldn't change at all because it's on the line y equals x. Right? But if I'm a little bit under it, I become a little bit over it, and if I'm way under it, I become way over it. Exactly mirrors y equals x. I'd recommend on Desmos.com, so if you go to Desmos, www.mouse.com. Right, you should graph a few functions and then inverses, right? You should graph the example we did earlier where we had 1, or it wasn't 1, it was 3 over x plus 7. And we found that inverse, and it happened to be 3 over x minus 7. And then I'd graph those two functions with y equals x, and I'd see this relationship stronger. Or you could graph any of the inverse functions we've already talked about to see this relationship in action.